Hello everyone, my name is Rachel Connolly. I'm the Director of STEM Education at WGBH, and I serve as the Professional Development Lead for the Worldviews Network. And I'm joined today by Dr. Kachun Yu from Denver Museum of Nature and Science. Kachun?
Hi everyone. So again, my name is Kachun, and today I will be talking about a Worldviews Network event that took place at the Denver Museum of Nature and Science on June 3rd or June 4th of 2013. And this event was on beetles. Well, actually, the title, as you see, is Forests, Beetles, and the Cycles of Life. And we will be going through the story and the storyboard and some of the things that we think are especially important.
So just to join in about the broader climate literacy framework that this particular story and program that you're going to be able to use hopefully in your institution, it connects to the larger NOAA framework through the following major themes. We touch on issues of how climate varies over space and time and how we have made a collection of environmental observations from different types of evidence that we're going to visualize in this program to tell a story about a particular ecosystem and some of the changes that are happening, in this case, to some forest ecosystems and the beetles particularly. So this is a nice program that you might want to bring into your institution if these are some of the types of stories you would wish to tell in your outreach and education efforts. So I'm going to turn it over to Kachun now, so he can actually lead you through some of the major points of the story.
All right, terrific, Rachel. So what I'm going to do is I'm going to switch over my, hold on, make sure I can do this, my display so that you can see what I'm seeing on my desktop. So you can see that we have UniView running here, and what's special about this particular presentation is that we will actually be using a browser set of browser pages to control a lot of what we are doing. So you'll see me switch back and forth between those two interfaces. And then finally, the other thing that you might want to have on hand as we are going through this is our storyboard. So you should have links for the installer file for UniView, how to set up the browser page, and then also this particular storyboard, which has the full narrative from our presentation from June of 2013. We have a description of UniView commands, screenshots, additional information on the far right column. And then if you want to just download one particular data set for use either in the dome or offline on Google Earth, for instance, we have KMZ file links throughout as well. So this is going to be a really useful resource that I will be referring to throughout my presentation today. So basically, what we want to do in this presentation is not only talk about climate change and the factor of beetles and how they impact western forests, but one of the hallmarks of the Worldviews Network is seeing connections at different scales. And so what we actually do in this presentation is talk about seasonal changes. And we start off in space and show the Earth as it goes through its orbit and seeing seasonal changes. And I'm not going to do that here, but the reason why it's important is that it allows us to connect what's happening at a cosmic scale, the Earth going through its seasons because of its axial tilt relative to its orbital plane, the ecliptic, but how it relates to what's happening on the surface of the Earth. And in this case, I've brought up a data set for the net primary productivity. And that's just a complicated term, but I think that all we need to think about what this is basically showing the intake of carbon dioxide by plants on Earth. And in this case, we're looking at plants in the oceans. These are microscopic phytoplankton, which have chlorophyll, and they pull in carbon dioxide and outputs oxygen. And I'm going to go ahead and start the cycle from the browser control. And what's really remarkable as we start seeing this is that let's see, let's see if we can start this over again. Here we go. Um, is that you see intense bands of greening where the plankton are really growing in the northern summer, and so you see them growing in the North Pacific, and then as we get into this southern summer, you also see a corresponding strong band of phytoplankton growing in the southern oceans as well. And we have a similar data set for the land plants, and so, but I'm going to go ahead and skip that. But basically, the idea is to connect all these, this particular cycle, the seasons, with the growth and retreat of the plants to the Keeling Curve. And I'm going to go ahead and bring up the Keeling Curve. This is the measurement of carbon dioxide in the atmosphere in parts per million. That's the y-axis. Those are the numbers. And then on the bottom, along the x-axis, we're showing the years. And so this started in the late 50s and continues up until the present. And if you look closely, you can see a bunch of wiggles in this curve, in this red line. And the wiggles correspond to the intake of CO2 by plants. And so in the northern hemisphere, where most of the land mass is, in the northern summer, you have a lot more plants, and so the amount of CO2 wiggles down, and then during the northern winter, the plants die off, or they're not as productive, and so the CO2 jumps back up. And of course, during the northern winter, it's summer in the southern hemisphere, but there just isn't enough landmass and plants in the southern hemisphere to make up the difference. But the wiggles are laid on top of this overall trend of increasing carbon dioxide. And in fact, we've already hit 400 parts per million last year. And so let's go ahead and turn off the slides. And I'm going to jump us to this other data set. Oh, hold on. Let me load a new layer set. And I've skipped over a number of different tabs, and there's actually a lot more content that is in this particular storyboard, and so I refer you to the storyboard narrative, the document itself, to learn more details about this. But I'm just going to be covering what I feel to be the most important things that we want to cover in 15 minutes. But here is a temperature anomaly map, meaning this is the difference in temperature over the last decade compared to the first 80 years of the 20th century. And what we're seeing is basically global warming or climate change happening now. So there is clearly a latitude difference, so that there's actually, I'm sorry, I turned on the wrong data set. That's actually temperatures. There we go. Let me see if I can find the right one. This is what I'm looking for. So there's actually a latitude difference. So there's more warming at the higher latitudes, and there's less at lower latitudes. And in fact, the southeast has shown a couple degrees of cooling. But there's also an altitude difference, so that as you go up into higher elevations, there's also more warming. And if you know your geography and topography of the United States, you know that the Rocky Mountains comes right down here, and so these little islands of warmth are places where it's higher, and so we're seeing much greater warming up in the mountains. And related to that is I can show you a temperature plot from a temperature station about 60 miles from Denver. This is up in Rocky Mountain National Park, and what we're seeing is the minimum January temperatures, meaning this is how the coldest that it gets in January. from since the late 40s all the way to today. Although I think this plot only goes up to 2010, but the more recent years haven't really deviated too much. So what you see is, again, an overall trend in warming over the last several 50 years or 60 years. But what is really interesting is this blue block at the bottom here. We see that this line corresponds to minus 30 degrees Fahrenheit. And what that means is that since the 90s, we have not seen temperatures dip below minus 30 degrees at this particular weather station. And that is important because the pine bark beetles that we are dealing with, their larvae are killed when it gets below minus 30 degrees. And so over the last 20 years, last 25 years, the temperatures have been warm enough that more and more beetles have been surviving, and as a result, they have been propagating, and they have led to a lot of destruction of the western forests. And so let me turn off this slide, and I'm going to go ahead and let us get back to this and turn this off. And I'm going to make this smaller. And so these beetles are naturally found in western forests. They weren't introduced here as an invasive species, but because the temperatures have gotten so much warmer, they have managed to thrive. And what I'm going to do now is I'm going to turn on let's make this a little bit smaller, and let's zoom in. So we have Colorado, we see Utah, and Wyoming, and New Mexico and Arizona to the south. But I'm going to turn on a data set that corresponds to a different year of beetle impacts. These are done by aerial surveys, and these don't show areas where the trees are completely destroyed, but they only show areas that have been impacted by the beetles. And so it looks a lot scarier than it really is. But as we jump through these different years, you can see that the effects of the beetles have been very pervasive throughout the western forests, going out into California. And there are different beetle species that eat different types of trees. So it's not all the same. It's not just a single species that's responsible, but we can show the cumulative effect. So all the data from the last 14 years or so. And then what people don't realize is that this is a continent scale phenomenon, not just something that happens in Colorado. You know, when Coloradans drive up into the mountains, we can see the gray and red dying trees in our forests, and you can literally drive for an hour and see a landscape filled with dying or dead trees. But people don't often realize that this is something that happens throughout the western states, and in fact, the greatest impact is actually in British Columbia, up in Canada. You can see that there are huge swaths. I mean, we were talking about millions of acres of trees that have been impacted. And surveys go all the way up into the Kenai Peninsula in Alaska. So this is indeed a continent scale effect. And this is something that really impacts our audiences. People just do not realize that the scale of this phenomenon. And so this is something that is really powerful for audiences. And then finally, one last thing that we can that I will be showing is just showing some of the impacts on the ground. So let's go up here and go back to our panels and slides tab. And let's see if I can find. So here is a panel taken again very close to that weather station I was talking about earlier. So this is near Rocky Mountain National Park. And what you might be able to see are gray trees. These are trees that haven't fallen yet, but they have been they have suffered the beetles that have burrowed into their trunks. And it's actually not the beetles that killed the trees, but it's a fungus that they introduce. Um, and when you drive up into the mountains in Colorado, you will see, I mean, not all the trees are impacted, but you'll definitely see a lot of dead trees up there. And so we have lots of imagery, static slides, as well as panoramas like this to show this impact. Now, one of the goals of the Worldviews Network is not only to educate the public about ecosystem um, problems that are happening in their region, but also to look for potential solutions so that we don't completely scare people and to depress our audiences. And unfortunately, the scale of these problems is so enormous that there's not much that can be immediately done. Um, we're talking literally about millions of acres. Much of these forest areas are very remote with very few roads, and even the roads that the dirt roads, um, the roads that you can take to get in, the fire roads, you are at risk of having trees fall on you. So it's actually kind of dangerous to go up there. But this is an issue that a lot of different agencies are worried about at the state and at the federal level. And in our partnerships with external advisors, we talked with the U.S. Forest Service, with the Colorado Forest Service, with researchers at local universities that are studying the life cycle of these beetles, that are studying the impact that the fallen trees have on water quality. And so in our presentation, we talked a lot about what various government agencies, what policymakers are thinking about, and about dealing with the landscape that will undoubtedly change, so that we are seeing these forests that will undoubtedly change over time, so that the forests of the present and of our past, the forests that we have grown up with, are not the forests of the future. And this is something that people will have to realize. And of course, there are certain things that we have to deal with as far as changes in runoff, the risk of wildfires when you have lots of dead wood laying around. And then, interesting enough, it's not total doom and gloom, because the fact that you have, it's not just the beetles that have caused this. There were land management practices in the past 100 years that have led to sort of a monoculture of trees in the forests, and as a result, there are things that have been done in the past that have made our forests more susceptible to these sort of impacts. And so, as a result, there are things that we know about management practices that will inform us that in the future as these new forests grow. And so, we have gone up there in the winter to places where the landscape has changed quite a bit, and the dead trees have fallen. And actually, this is an area where we've actually removed some of the dead trees, but as you can see, new trees continue to sprout up, and young trees are more resilient to the beetles. And so that was our little message of hope to our audiences. But the main message is that our forests will be changing in the future, and this is something that our audiences will have to be prepared for.
Great, thank you, Kachun. I just want to sort of end, if you have any final words, I would like to just sort of end by saying that I hope this has provided you a sort of framework for, at least at the cosmic and the global level, you can tell this broad story about, the carbon cycle and the environmental and seasonal changes that are happening. And then maybe if the beetle story is not one that is particularly connected to your region, in that you might want to find another story that is similar to how a particular ecosystem change is causing species to have impacts like the beetles are. So maybe this isn't the exact story you'd like to tell, but there's parts of it that sort of set you up to tell your own local story. So, Kachun, do you have any final things you'd like to say?
No, other than thank you for joining us on this broadcast.
Great, and for more resources in that, please see worldviews.net, and feel free to reach out to us on that website, and thank you again for your time. Bye.